Hello ladies and gentlemen, what's up? This is Papa Bale and I'm pleased to bring you the 2-magnet rotor test. The constants in this experiment have been the coils, and that's on the far rotor over there. The coils have been the same through all the experiments. They are 666 turns of 20 and 30 gauge wrapped parallel in a bobbin. So we got 1 for a trigger, 30 for the trigger, 20 for the drive. It's a 12 volt test. That's the other thing that's been constant. It's been 12 volts. The reason we're not drawing any amps is because I haven't turned it on yet. We're just putting voltage into it. We're going to jump start it. Okay, so moving right on, we're going to go to the other side. We're going to start it from the other side. It's just so we get it all going the same direction. Let me zoom out a little bit. Back in. All right, here we go. 1, 2, 3. Get a little bit of momentum there. All right, now this one wants to go. That is moving right along. Look at that awesome design there. So we got our SG light flashing. One there and one there. So those circuits are functioning. .500. So that's our lowest reading, but that's not to be unexpected. 506. See what trend we're doing right now. 508. So we'll give it a couple of minutes, well, more like 30 seconds. See if it chooses to increase in speed any farther. This little 4-magnet rotor is whipping right along, and say right around the same speed though, right around 550, 500. Yeah, so the wireless transmission of electrical power, whether it be close enough for a spark or whether it be up to a mile or more away, is where we're going with what I want to achieve in order to get my machine, my pulse motor with the Utrons and everything going. I believe we're going to need a remote control. Just saying. So that's part of the agenda, and it's a whole another learning curve. Dang. Alright, this is already slowing down. Alright. Well, 500 max for the 2-magnet rotor. And it's going between, the amps are really fluctuating. I don't think that's normal. Going between like 2.1 amps and 2.8 amps. Now that it's at 2.0, I think I'm going to take another tach reading. Something's got to be going faster than it was just a second ago. Oh, it's starting to slow down again. .630 and 502, so they both kind of sped up a little bit. I wonder what's causing the amp draw to fluctuate like that. And I wonder if I remove the resistance from this SG circuit, like I removed it from the one over there, if it'll function better. Or did I put it back in? I'm not quite certain, but I've been fooling around with resistances actually going to less than 100, going to like 68, 47, 22, 10 ohms. Tried all those. 68 worked real well. 100 worked. I tried putting 1,000 ohms on there, it didn't even function. Tried putting this in there, didn't function. Not worth a damn. So yeah, I don't know what the dealio is with that. I did notice the difference for each resistor that I chose. There was different frequency or RPM, you know. So I know they do stuff. Apologies. So I'm thinking about taking the maglev off and just have it rest on, like I was saying before, I have phalange underneath here. And right now it's magleving, so it's probably getting a few more RPMs than it would the other way. But see that little metal thing right there? The thing, yo. I can't really put this down. Let me put it right here. So it was like we thought. It went 6 magnets, 12 magnets, 4 magnets, and then coming up as a distant runner-up is 2 magnets. But all that might be better for energy generation depending on timing and placement. You can get an 800% output with 2 magnets, with 180-degree magnets. It's amazing. It's called an Adams motor. And it's all based on how you set that stuff up and where you put it. It's amazing. Truly amazing. Never looked at how to build one or built one myself. But, you know, the style of my build is kind of reminiscent of an Adams motor or a Bedini motor. But I have never looked at I might have glanced at something that somebody gave me. But seriously, if you're sending me a schematic of something that's been done before, I'm really not going to look at it that much. And all this has been like done before, quote unquote, my quote. But, you know, I like figuring it all out. Not all of it, but, you know, stuff that I can figure out for myself, I like to figure out for myself. So, I need to take off the magnets. And I'm going to do that. In the meantime, thank you for tuning in. Hope you enjoyed our demonstration. And for closing remarks, it is this order: 6 magnets, 12 magnets, 4 magnets, and 2 magnets from my speed data, RPM wise. For the same in, every time we put the same amount in. Every time the same coils were used. Every time the same rotor was used. We just had different amounts of magnets in it. So I would say that's pretty good, unless it's also determined by the other pulse motor that the collectors of this pulse motor are hooked to. I know it's a tongue tangler. If that has anything to do with it, the speed of that motor or anything, then I don't know. Maybe that prejudices my experiment a little bit. But it's been pretty. I did change out the rotor once, but I changed it back because I didn't want the experiment to be changed in any way. And luckily, for me, it didn't change anything. But I just, for the sake of continuity, I wanted it all to be the same. I just had an impulse, and I fixed it. All right. Peace out, ladies and gentlemen. Have a good night. Bye now.